kids, Mark Miller here. Welcome. Roy will be joining us in about an hour. Just before we started, I was just in the middle of adding a smoke effect when the fireball is crushed, and so let's work on that. Let's get some Code-Rush music playing here. Just want to get that the smoke from the extinguished the same color as the fireball. And this is going to happen when we destroy it, when we call destroy all tracking effects. So this is basically saying, hey, is there a fireball? We're going to extract all of this to destroy fireball. Destroy all fireballs. Like that. I also added handheld smoke here. Handheld smoke is okay. It doesn't look great. I'll show you both of these. Let's refresh. But I think the work we were trying to do yesterday with regards to those are both. All right. Here we go. Let's see if we can get that to work. Here's smoke effect. There it is, right there. So it's not super great, right? It looks a little too rigidly placed in space for smoke, right? It's jumping around a lot. What I want it to do is what I want the smoke to do is I want it to behave a little bit more like smoke. So I want it to move more smoothly, and that's one of the things we were working on yesterday. We didn't quite get that. We didn't get that working at all. Actually, I was going to say we didn't quite get that working, but you know. So that's kind of what we're looking at. It's not bad there if it's in my hand like this, like that kind of a thing. Anyway, that's that. There's the fireball. Right there. There we go. Let's see if we can get this, if that smoke works now. Well, look at that. We've kind of got the smoke coming up there. There's the smoke. It's got the matching color, but it's playing in a loop. That would mean that was my mistake. Go sequential, so it goes to the end. Refreshing. Well, let's try now. Hold on. Still in the loop up there. Why is that? Oh, duh. Wrong one. It's smoke extinguished. It's this one. All right, one more time. Okay, there it is. It's way up there. Okay, I think we got a positioning problem here. Got to get it scale. Y in the scale, we got to figure out the scale. Constant scale. No, I want actually something else first. We go get that data from it. Oh shoot, it's not here. Okay, it's just in Fireball itself. I think that'll work. All right, let's give that a shot. Extinguishing. It's not finding the fist, it seems. There it is. We seem to be off. All right, am I choosing the wrong one? Actually, let's get the results of this too. All right, see how that goes. Nowhere near. It's low. Doing that as a throw too. Let's see here. I'm looking to see, this is where we add the rising flames to it. So we're taking an existing position and we're figuring out what its Y and its X are. And so we're taking the fireball sprite X, adding its origin to it. Yeah, interesting. Well, let's go back because I thought we tried that to start with. Yeah, we did not multiply by scale though. Let's take out the scale multiplication and switch it back to where we were. Using the origins of the fireball. So this just kind of determines the anchor point, the centering of it. Let's see if that solves that for us. Just kind of warming up with this effect here before we dive back in. That close is consistently getting captured as a throw. I have an idea as to why that is. Not getting the fist at the close fist there. There, kind of gets it a little bit. Huh. I was getting pretty effective closed fists before. Let's show the hand position here. It is interesting that it says, oh, my hand's pointing backwards when I make a fist. It is definitely not that. It's interesting also, we're now over here. Is it because my hand is tracking the leap on the other side? I want to make sure my hand's not. definitely not detecting a fist. Guess I'm going to go after the fist problem. Let's just set a breakpoint here to see where when we arrive here. Okay. Let's make this a little wider. Set that breakpoint again. Okay, we're there. There. There, we hit it. Good. Okay, seems more reliable now. All right, let's see if we can bring a fireball. This. How are we getting that throw? That's what I don't understand. It's going to be in something we call get throw vector, I think is what we called it. Yeah, sometimes the data isn't quite right. There we go. Now it's got us. I'm thinking also about taking this and moving it back to about here, like right over the space bar, but somewhere in this space. I think my hands can get on either side of that. Just need a little bit longer cord here. Thinking about doing that, just because it gives it allows me to bring my hands back further with greater accuracy. Notice what's happening back here. It's just not, the accuracy is just not great when it's back here. The accuracy is at its best right in this space right here. It's not bad. The fingers are way off, but I'm not too worried about the fingers because I'm really only want their relative positions. That's what I'm looking for. It's definitely feeling a throw in here, just in that close, which is a little bit stunning to me because we're just looking at the escape velocity time. Roy says, perhaps when a throw is invoked, consider capturing a snapshot of the data that led to the throw being executed, sort of a last throw diagnostics. This can be rendered as part of the entire existing diagnostics. Yeah, okay. Frank is rating with a party of 31. Welcome, kids. Surly Dad.
Surly Dad is in the house.
How you doing, Frank? Welcome with your raid. Super appreciated, everybody. How was your stream, Frank? Hope everything was going well. We're in the middle of playing with we're in the middle of playing with virtual fireballs today. Looking at that code. Right now I'm looking at trying to figure out why I'm getting a false throw in here. If I come in here and I go like, give me a fireball. Hey. There's my virtual fireball right there. It's not too bad. Doesn't look too bad. There it is right there. I'm going to put it out of my hand there for you to take a look at. You can hear it if I bring it closer to the camera. Bring it further away. A little bit different sound there. Yeah, fireball. I can throw the fireball. It's kind of an okay throw. It looks a little spazzy, to be honest. Yeah, I don't like that part where my hand kind of comes through it. I kind of have to, that's the weirdest thing I've ever seen in my life. Got to fix that. But I can throw it up and I can catch it like that. Like that. And so there's the fireball right there. There, you can see it right there. And I think if I look at it, it looks a little more believable. That's what we're looking at. That's what we're working on. Yeah. So that's what we're working on, kids. Yeah, fireball dancing. Only here on Code Rush. Are you using a Kinect? I'm not. I am using a Leap Motion device right here. It gives me skeletal data on my hands. We've added some math to correlate the three-dimensional data, which is actually, you know, beautifully presented to us in a world of millimeters. So you basically get coordinates of all the bones in the hand to millimeters. Its accuracy is it's usable. It's not bad when the hands are right in the zone and it can it's a good view of the hands. We're good. But if I like turn my hands away like this a little bit so that the camera can't see through my through my the palm of my hand, the back of my hand into my fingers, the accuracy drops significantly. So if we get outside of its range of view, not so good, but up in this space, it's pretty good. And the whole point is to do this to see if we can kind of create these virtual fireballs, which if we do get those working, we're going to, and we like how they look, we're going to use them out on this show I just put in the chat room, or maybe down there, depending where your chat room is. It's Dungeons and Dragons. And so it'll probably be used in that way. So somehow we're getting a throw. Roy wants us to, let me go just get out to, it's it right there, get throw vector. When we get throw vector, at some point we get to here. And I think that's what I want to do is I want to look at the data when we're there. I think I'm just going to look at it in the, there's the throw. Now here's what I don't understand. This hand should be in a fist. Well, okay. So let's say we're throwing. The speed, fastest throwing speed in there was 1430. That is millimeters per second. That feels like kind of a false bit of data there that we've got. Here's the cue. Really got 128 of these in here. Starting at 10:09 a.m. All these are, oh, look at these, only going to 25. And that's about a second later. Okay, so somewhere in here, it looks like we have exceeded our min velocity for a throw. We definitely have done that. And our speed is now much smaller. I feel like we might want to add, let's just keep running here. We might want to add a question of what is the distance, a minimum distance, or in time probably, in which that minimum velocity is reached. So in case we get a spike all of a sudden and then drop back down, it's still not a throw. It's got to be, you got to hold it for like about 1/10 of a second or more, for example. So that's maybe what I think I might add to this. Could use the debugger display attribute to make that list of velocities more readable. Yes, that is a good point. I don't think I can do it while I'm running though, so I think I have to shut down to do that. Let's go do that. Anticipating that I'm going to need to do that. And I'm forgetting what the syntax is on this. What the how do I encode that string here? Got a link for me? That's what I need. Okay. Something like that. So we're going to say let's try that. I think that's going to work. Okay. Just make sure I got that right. Okay, let's try it. Oh wait, you know what? I don't want time. Hold on. Let's close this down. I really don't want time. Time's not going to help me much. I need. Maybe I need that. I think the long string is going to give us, let's take a look at that. No, I don't want that. I want time with milliseconds is what I want. ToString. It's the millisecond component only. I'll try that. I suppose I have to do this and this. Let's see if that works. Just doing time of day, which gives you time span of the time with milliseconds. Self-Kimbley, that, you know what, I'm going to stop the app and change it to there. I like that way better. Yeah, I was like, why don't I get total milliseconds in here? So time of day, is that what it is? I love it. Love it. There. That's what I want. Let's do that. Let's really speed. Okay. It's not going to show me whether it's forward or back, you know, whether it's got a, you know, which direction it is, but I think I'm okay with that. I think I'm okay with it for now. All right, thanks for that, Solf Kimbley. That was awesome. I love it.
Awesome contribution!
Okay, put this, let's go ahead and we'll click on the active right here. That'll turn on the leap for us. Hit the fireball button. There's the fireball button. Let's go set our breakpoint. So we can see better data now. Let's move this off to the side. We didn't hit it that time. Interesting. Oh, there we go. We got it right there. A little bit. Let's see if we can see the data. Bunch of nulls. There we go. Need some noise reduction here. A lot of milliseconds. All right. At any rate, we can see the time is increasing as we move forward. Speed, 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 speed. This is all... Okay, here we go. We bump up to 1367, and then we're immediately down in just a few milliseconds below it. I mean, afterwards, right? We're going from 57, 66 to 77. So 20 milliseconds later, we're down. We're kind of back up again, but I kind of feel like we need to do this for at least, I think like 1/10 of a second. We need to be above some minimum threshold to count it as an actual throw. I'm going to go ahead and run it, but I want to look at the, I'm going to clear the breakpoint, run it. I just want to look at the code, review the code here for this. So this part right here checks to make sure the data is fresh. So we have fresh data. We get the magnitude. We check to see if the speed is greater than min velocity for throw and is valid throw direction. Escape velocity reach time, we set this the first time we're greater than min velocity for throw. If speed is greater than fastest throwing speed, we continue to track. We track this first time in, it'll get this data as well. I think we need at least one more Boolean or alternatively, we need to reset all this data if speed drops below and the time since escape velocity reach time. I think it's going to look like this actually. Do I need to get a fireball? Okay. So I think it's going to look like this. If we got a valid direction, no. This is going to go inside here. If valid throwing direction, then we're going to do all of, whoops, that. But if the speed is below it, right, we're not here, and if escape velocity time is not min value, meaning we've reached, put this up here actually. So the situation is here is velocity is slower than min velocity for throw, and we've set like fastest throwing speed. So now what I want to do is I want to say, hey, if the checkpoint where we've slowed down, its time minus escape velocity reach time is less than, and here's that minimum right there. Also, the value of 1400 is sufficiently high for millimeters per second of a closing fist. Yeah, I think it's bad data, Rory. I think it is. I think it's like a jump in the leap because of the quick motion here. It's like, wait, was that a fist or was that a was that a hand movement or was it the palm moving? So if this is less than if it's less than 1/10 of a second, well, let's just say it's less than 1/20th of a second. Okay, then what I'm going to do is I'm going to reset this. What's my throwing time? When's that set? There. Escape velocity, reach time. All of that. Anything else that needs escape velocity reached. So I need to get that and escape velocity reached and reset all of those variables right there. And escape velocity reached, set it to false. So as we go through, even if we slow down, once we get past this point right here, we'll continue. This will continue to be false, and we won't come back here and reset it. I think that's what I think. Let's set a breakpoint in here, and set a breakpoint there. Let's hit continue. See what happens. Oh, already inside of here. Maybe I won't set a breakpoint here. Let's just try it. We did get a throw here. Let's bump that up a little bit. Keep doing my breakpoint. All right, let's try it again. That's really funny. Okay. That feels much better. I'm not getting those false throws. There's a throw. All right, let's run it. Just play with it for a minute. Over there. Really? Come on. Seems like I had to seems like the throw took a little more. There's a little bit of a bounce before the release of the throw, which I'm not happy about. Kind of pulls back for a second before the throw is released. Not sure about that. It's too far back to catch it. Why did that show up there, though? That was weird. Is it because of the positioning? It's going to do it again? I'm not sure. Should be off screen. Should get it from off screen. I think we're okay. All right. It's not too bad. All right, let's go back and look at, we've got Roy joining us in a few minutes here, about 12 minutes it looks like. Let's get focused on the problem we were working on yesterday, which is we want to get the fireball to kind of spin around like the point that's coming off of the finger. Here comes Jetsam. Hey, Jetsam. Jetsam is in the house. Yeah. Good morning, kids. So what's happening is there's this part off the palm that's calculated. It's kind of coming out about that far off the palm, right about to there. So as I move the palm around, that's where we're positioning the center of the fireball. But what I want to do is I want to make it so that wherever this goes, it's kind of as if there's a spring between it and the actual fireball. So I want the fireball to be kind of like, as it gets stretched out more, to really accelerate towards it. And then as there's just a little bit for it to just kind of follow and hover around it like that. That's what I'm hoping to do. We wrote code yesterday to get close to that. Did not work at all. We had completely no evidence of it working, but we also had no diagnostics data. So I think I'm going to head in the direction of diagnostics data for that. And we'll see what we get out of that. See what we get. Okay. All right. Physics is where I have get final velocity meters per second. That's used from get final velocity. Here's the code we were working on over in hand 2D. This is where the problem seems to be. Let's bring up our notes about this. Did we draw anything in here yesterday? Actually, I'm thinking maybe we did not. Where did I put this? Yeah, it's not here. Oh, I think I didn't save it. That's what happened. I shut it down and did not save it. That's what was going on. All right, so let's kind of create something new here. See if we can recreate the logic here. So we basically want a spring, like trail calculation. And we're doing it with our this floating attach point here, which has got a position, last force, velocity, and snapshot time. And we've got an object out here in space, and I'm just going to look at it only in 2 dimensions. You've got some sort of like spring force pulling it towards a target. Like that. It's got a spring force pulling it towards a target, but it also has, and I'm looking again, like I say, only in 2 dimensions. It has a velocity. Let's flip this over so it's pointing the other way. Some sort of velocity. And it's got a position. And it's got a time. And what we want to do is we want to use the velocity, the force, and the time to calculate the new position and the new velocity. Because we need to store both of those so that we can come back and use position and velocity again the next time we want to calculate it. And the new snapshot time. I'm not sure last force is actually going to be used. I don't think we're going to need this. I'm just going to grade that out a little bit because I think we're not going to need last force. We're just going to need position velocity. So that working in 2 dimensions or in 1 dimension should also work in 3 dimensions. We just apply the rules for each of those components, X, Y, and Z, for each of the dimensional axes. Okay, that's the essence of it. Let's look at the code. Let's look at what's going on with last force first of all. I'm pretty sure we're not going to need this. Get final velocity. Yeah, I'm kind of disagreeing with the logic anyway. I don't. So the last force is only used here, but I don't think we need to do that. We can instead store that in the attach points velocity right here. All right, so let's try one more time. Force vector uses this equation right here. F is equal to negative Ks, which is Hooke's law. Although look at this, I've got it multiplying by a kind of a positive number here. This could also explain why we're having this weird problem here. So I'm going to say, oh, it doesn't like the change because we're running. Okay, I'm going to make the change anyway. Let's see if we can trigger this. Okay. So get spring vector. There's our force vector. Is this because this is a... Whoa, 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 whoa. Are these the same place? They might be the same place. That's why it's 0, 0, 0. Are these two the same numbers? 13.69. Sorry, position. 13.69. They're the same number. Okay. Force vector, because I think we're starting out, as we're starting out, it's in the same position. That's my guess. Now what I want to do is I want to say, I don't think I want to do this. I think I want to do this. Let's say its velocity is actually, let's say that the velocity is already good. Yeah, it looks like I definitely have a code I'm not liking in here. I think we want to work with the current position. And then we want to say, hey, on that current position, what is your final velocity to get it? But I don't think, like I say, I don't think I need my final velocity. I think I need position, current position is equal to position dot get current position. Then we're going to pass in the force vector. And the initial velocity, we're going to say, is in floating attach point dot its velocity. That's what we're passing in. And the delta time is going to be delta time. Right there. Now, I think that's going to get my current position. Then I want to get my final velocity after I do that. And that's going to be equal to, starting with the position, not the force vector. I'm not sure why I wrote that. Get final velocity. And I'm going to pass in the force vector again. And the original velocity and the delta time. And now with both of those, I'm going to then do that, update the velocity and the position, and update the time. Let's see what happens. So we've got am I reading this right? That is, let's look at this, open this up. 3 minutes. It really is 3 minutes minus the snapshot time. Current position is the same position as before. I recognize those numbers. The force vector is 0, and the velocity is also 0. Perfect. Final velocity. Is that right? I want to see how I'm using this down in the overlays.
Hello.
Roy, can you hear me?
I can indeed.
Can you see me?
I can see you now as well. Yes.
Oh, that's
excellent.
awesome. Those are my killer dance moves, Roy. That's why we're here, really, for the dancing, I think. I wanted to come down.
We come for the dance, we stay for the code.
Yeah, exactly. I want to see what's going on here with my calls down here. I'm just calling it, saying there's my final velocity X. That's all I'm doing. Yeah, I think my code is wrong in the C# implementation of this. Flat out, that's all I'm doing. Yep. All right, so we are... Look at this. I've got some bet I can change these and make it happier. Hold on, no, we want to let here. Okay. All right. Yeah, so I just realized my code is wrong up there. So remember yesterday, Rory, when I said, hey, doesn't this look good? You know, I don't know what I was smoking some kind of crack, I think. I don't know.
Oh dear.
I'm sorry about that. You know what I mean? I'm just totally. Where are we? We're in drone. This is some of the first code we ever wrote, Rory. I think this wants to be const is what it's telling me here. Number, fine. Can infer that. You probably want to be consts as well. I know I'm slightly distracted over here. Nope. We want these to be lets. I know I should just hover over. All right, so before I get too distracted over here, let's go back and fix this. This is not right. This is not right. This should be velocity X is what this should be. Velocity Y and velocity Z, and therefore this should be that, and that. That's what it should be. The only thing I'm not sure about is this call. I'm also not sure about this meters to pixels call. I think it's right, but you know, not 100% certain. So get final velocity. I think this should be my initial velocity here. I want to change this. I'm going to kill the app. Second. I'm going to call this initial velocity. I'm going to kill that. Then I pass, so I operate on an initial velocity. That's what I do. All right, so now, and the code looks better. See, I've got position.getCurrent position and velocity.get final velocity. All right, and then I reassign those pieces right there. We'll see if it works. Still with me, Rory? Hey, buddy.
Sorry about that, Mike. They just seem to drop out altogether there.
No worries. All right. Who's ready to see this work?
Oh, I think that'd be good. I'm ready.
Are you ready? I don't think it's gonna work, but we'll see. Let's see over here.
Well, there's a difference between me being ready and maybe the code being ready.
Yeah, the code's not ready yet. Let's step through it. Let's look at, see what we got. First force vector is 0 because we're starting off at the same spot. Final velocity is 0 because we're not moving. The current position is the same as the position we're starting, so nothing changes the first time we're in. Second time we're in, let's see what we got. Uh-oh. 35,862. The second time we're in, now I'm a little bit worried because my attach point seems to be the same. What's my call stack? How am I getting in here? Get attach point 3D. Okay. Left hand float point, right hand float point. Was it null? Did we get this line of code first and that one too? Is that what we're seeing first? Is it re-nullifying it out? Wait, hold on. Maybe it's not. Now I got a force vector. Okay, cool. I'm maybe way off screen with this e to the times 10 to the 6th. Final velocity is huge. That's leading me to believe that maybe I got a problem here. Let's switch that up. See if we get another breakpoint. See if we get numbers that seem a little more reasonable. Yeah, we're way out in space right now. So we just nulled that out. Okay, there's the first one. Again. Ludicrous speed! All right, there we go. I've got some zeros right there. I'm running it again, second time in. There we go. Okay, this is better. These force vectors are definitely better. Oh man, the position is way out. Way, way out there. I almost want to stop my breakpoints for a second because I am messing with time. And I want to just see what happens with it. We're not going to see any difference in the behavior. Where are we? Come on. I said that. I thought we were not going to see any difference in the behavior, but we're seeing a difference in behavior. Which seems to indicate we've got a problem data coming down. Hold on one second. Just asked one of the kids to shut my door. They did that. All right. Oh, we have lost. I see what's happened. We've lost signal R connection. So we have to kind of restart because I've seen this happen at times when we are debugging for too long. At a breakpoint for too long. So let's restart it. So we're back to doing the test before. You still with us, Roy? Wow.
Hello,
And
once
you're back.
again. Having all kinds of network connectivity issues here. However, I'm now on a wired connection, which should make things a little easier, hopefully.
All right. I'm glad to hear it. Okay, so this is the same behavior we've seen before. Now what I want to do is I want to get my, I want to look at my floating attach point and use that instead down below. That's going to be, I think, in here. There it is. Floating attach point. Get floating attach point. Get floating position from side. We want to replace get hand position with side with get floating position from side and see if it works. And I think this is going to be like, I think we're going to get confirmation of what we just saw before, data all over the place, unless the data was influenced by time, right? That just because the time was so much further. And I think if that happens, Roy, we're going to have to dive down into the numbers.
Yeah.
I kind of want this to work because I don't want to be like all, you know, numbers. But yeah, it's nowhere in sight. Whoa, I said nowhere in sight, but I saw it for a second.
Yeah.
Well, that was interesting. Nowhere around.
It's almost like the graphics have stopped. You can hear it reacting. It's getting louder and quieter and what have you. I think there was even a throw went off, but the graphical side was just missing.
Yeah. Yeah, it's getting all those pieces. Yeah, it's far away. Okay, so we need to go back and look at that again. Oh, I just remembered I'm converting meters to in my velocity. I'm converting
Millimeters to meters.
meters to pixels or whatever like that. Yeah, I need to go look at that. Not here. Here. This, I need to get rid of that code right there. Pretty sure. Because the velocity is already going to be coming in the whatever units we want to use.
Ideally meters per second.
I believe. Well, that's what I'm...
Well, no. Elite Motion's velocity is coming in millimeters per second.
Yeah.
And our equations are designed to work with meters per second, so we do need to convert that.
That's my recollection as well. Let's see if that makes any discernible change. I don't think it will, but... Well, okay.
Well, that's a change.
Check that out.
How many fireballs did you want?
No, it was spinning around it. It was in orbit.
Oh, right, yes. It's getting faster and faster and then achieving some form of escape velocity.
What is going on with that?
Is that just a negative? Are we projecting it away from the center instead of pulling it in?
No, I don't think so. I think what's happening is it's like too much spring is kind of what's happening, because the distance is happening, the force is increasing as it gets further and further away.
Well, that's what I mean.
Shouldn't that pull it in?
Should be pulling it towards the center. It looked like it was getting further and further, suggesting we're just pushing the force in the wrong direction.
Yeah, we can try it. We can try it, but I don't think that's gonna. We'll see what happens. Let's try it. What the heck? We'll do it. Give it a negative. I think what's going to happen is you'll see it go shooting away. Because right now it's curving towards the inside. So, you know, I'm kind of like... Yeah, we don't even see it with the negative now. Oh, whoa, it got the throw. Hold on a second. Yeah, it gets the throw because it kind of knows where it is. It does the throw from where it is. So yeah. We're closer here. I think it's this. I think that number's got to be dropped. Is what I think has got to happen. So we'll take this negative off. Let's try 0.3. What? Okay. Sometimes I say what loudly in this show. You never know. All right, so let's see. No? Whoa. Okay, hold on. How did it go from a 1 to a 0.3? Look at that. I mean, it's kind of cool, the arc.
Yeah. But the orbit is now much bigger.
Does that mean a 1.3 will do something different?
Well, you were on 3 before.
Yes, you're right. I was. You're right. I don't know what's going on, to be honest, Roy.
So I'm thinking this will be smaller than what we just saw, but bigger than the original.
Let's see what happens. I'm not getting this at all. There's something definitely going on with the number here. You want to go at a 10?
Yeah.
Let's try that. All right. Oh, man, I feel like we were really closest with the 3.
Yeah, I think that's probably true.
I'm going crazy now. I'm going to go to 100 and see just how crazy we get. Yeah, it's like immediately dying because it's shooting off screen. Let's go back to the 3 we had. What's up with this magic number 3? Let's do 2. Got 2 hands in here. I got to get rid of the other one. Okay. Fireball. 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 What?
Okay, so I mean, let's just put it back how it was.
I guess we're well trained.
Because
The software's teaching us how to code. Okay, where is it? Why do we not have... Need to switch over here, I think. Is that right? Get the hand tracking data. Hand tracking data is frozen. Was that a breakpoint for too long? Yeah, it looks like I might have been.
there for very long. But
Yeah,
okay,
it's
could
not.
be, I
It's
suppose.
not responsive. Not responding. Let's restart it. Okay, we're back to where we started, Rory.
Uh-huh.
What?
Software says don't touch that dial. So K is our constant. It's our measurement of tension, essentially.
Yeah.
Then there's a force vector, which we're multiplying that by.
And we tried moving it closer to 0. I don't think we tried making it negative. We tried taking it to 100. It was too high. It was odd as we moved it closer to 1. It seemed to be getting bigger. I'm like, what? I just wish we were smart. You know what I mean, Rory?
I wish we could get consistent results that we could then modify and, I don't know, learn something from as we would go. It's like every time we have this inspired direction to go in, we creep that direction and wildly different things happen than what we're expecting.
Yeah, we're back to 3 now. I think, is it based on its position? So 3 doesn't even work at all. When I was hitting this before when we had 3, it seemed to be working fine. It's like completely gone.
So, did we change something we're just not aware of? Is there anything on the undo stack that would, you know, if you undo enough so that it goes through all of our previous numbers and back to 3 again? This is a kind of an excessively silly idea, but...
Well, I made it, put the letter F there.
Yeah, but that surely isn't gonna... Does that change the type of mathematics done and thus rounding issues? Are we going from integer to float mathematics?
I don't think so. I don't think that's possible.
That shouldn't be, should it? I mean,
What?
and yet...
What? You're telling me I'm going like
There's a
this?
difference between 3 and 3.0.
No, this is insane. Since it's declared as a float, the F should be redundant. Exactly. This shouldn't be what we...
Sure. You've not saved that.
But I'm running. It doesn't matter.
Oh, okay.
Now it's kind of in a weird place. Those are the dead ones. This really looks like there's a
I'd just like
difference
to
here.
point out that those who say it's not rocket science have clearly never come across fireball science.
Oh my God, Rory. What is happening?
I mean, I won't call it success, but we are talking about the difference between utter fail and considerably less fail.
All right, well, I'm going to try...
0.0.
I don't even get this. Does this mean float vector's got an operator overload for an int and it's thinking this is an int? Because
Is correct, though. It's declared as float. The
Yeah.
F is technically redundant.
there's no way that we should be seeing a different behavior here at all. I do want to try, though, a number 2 here. Just a 2,
Sure.
like that,
Yeah,
without
switching
the
the
F.
scale, but not altering the way of expressing it.
I feel like I'm a little insane right now and somebody's punking me. Nope, the problem is bigger. I think we saw this before. Okay.
So we go bigger and go like 5 or more, but again with still the same expression. This is
I really think it should be 0.5 is what I think it should be. That's what I think it should be. Like that. It's gonna make me do an F right there. That's kind of what I feel like it should be. It should be some force that's multiple of the distance. Let's try one more thing. I know this is a little bit crazy for me to keep trying at this. But I want to try a negative on the 0.5. See what happens. Wow. We're just frozen in space with that negative. Okay. So our best results, stunningly, are when k is equal to 3. That's our best results so far. I'm going to throw k at 5 and see what happens. Okay, I'm just stunned. We got to have to look at the data, I think, Rory.
Yeah.
I'm stunned, stunned, stunned.
I'm curious to find the difference. I mean, the things we're seeing go wrong should not be possible, okay? But that makes me want to question the obvious. So, for example, if we have a breakpoint on line 171 there, and we examine the contents of K when we've just assigned 5 to it, or should we say 3 and then separately 3 as a float?
Yes.
That shouldn't have any difference. That should not be possible. But at the same time, it's a measure or an observable difference. So we should perhaps check the data.
Coding Gorilla is asking, when does it apply this spring force? Anytime we get new hand data, it applies it. That's what's happening there. Get floating attach point, get floating attach point. When we create a new hand, creating a new hand happens when we get new frame data from the leap motion. That's what's happening. Shouldn't only apply when the hand is in motion. Kind of. Not really. Because the thing is that
we're effectively acting as if the point that is attached to the hand applies a sort of a gravitational force on the object that's floating. So it draws it towards it. And even if the two are technically static, that will also still apply a force, albeit a very small force because of the very small distance between the two by that point.
Yeah.
It's like, you're sat there in your chair, wherever, you have gravity acting on you, even though relative to the Earth you're not really moving anymore because you've reached a sort of steady state.
Yeah. Why does we apply a negative velocity to something that is not moving? Yep, that can happen at the very beginning. It's actually a velocity. We're applying a force to something that may not be moving at the beginning to get it closer to this piece. So if we're far away, it's a big force we apply, and we're just a little bit there. It's a little force. Now we do have.
The question is more that are we applying a force to the hand since this is happening in hand 2D? I did not think we were. I think that was kind of a bit of a confusing.
No, we're not.
Thing.
No.
The hand data.
What we're doing is we're getting the spring vector. So the further away it is from the hand, the more powerful it's going to be attracted. So we're trying to create this kind of spring-like motion. That's what we're trying to create.
Yes.
All right. So the thing that's stunning to me is these different, the different things we're looking at. So I just want to say, so force vector. Let's get down here, is equal to that. So let's do this. Force vector times 3 and let's do force vector times 3f, and the numbers are the same. So
Okay.
what? Why was...
I mean, in fairness, that's what we would normally hope to be the case, and yet the demonstrable effect of those identical numbers is very different.
Yeah. Okay. Attach point, that's what we're going to go to, minus its position. Yeah, this doesn't make any sense to me. Force vectors here get current position based on the force, its initial velocity. All right, let's get out of here. Yeah, I really am thinking like 0.7 or 8 or something. This is what feels like is the right answer right in here. All right, so let's look at the current position here, which is we're currently at about 1,000. Z is at negative 1,800. I'm just looking at that, thinking that's pretty way out of bounds already. Yeah, I really want to get here the first. Let's just run this a second. Let's see if I've blown my SignalR connection. Nope, we're still good. Okay. I guess I slightly misphrased my original question. Shouldn't it only apply when the fireball is in motion? No, it's only applied when the hand is in motion. And that's currently where it is applied. Because we're trying to get it to stick it to and attach to the hand. That's what we're trying to do. Trying to see if it depends on position at all.
Sorry to say so, Mum. I disagree. I disagree with you and Coding Gorilla. I think the force should be applied to the fireball at a magnitude corresponding to how far away it is from the hand, irrespective of whether either one of them is in motion or not. So there's a large amount of velocity applied to the fireball in the direction of the hand when it's a good distance from it. Then as it approaches, it is reduced to a smaller velocity because it is close to the thing that is attracting it.
Yeah, that's essentially, I think, what we're doing. We're also incorporating its final velocity, though, right here. And we might take that final velocity and dampen it by some amount. Right? Like that is, there's this idea that is like, well, we could like say, let's multiply that by 0.5, for example.
Okay.
And that will dampen that final velocity out. I don't know, let's see if we get any better. We still got that 2 up there, which is not working well. Yeah, I think I got to change it to our magic 3, which is still blowing my mind. Oh, it's up here.
It's 0.8 at the moment.
Yeah, 0.8 at the moment, you're right. Let's change it back to it. I'm going to do a 3F again because I can't believe my eyes on this. Yeah, nothing. And wow, that 0.5 final velocity, I didn't like that at all. That's kind of stunning to me. By damping that.
When you initially set the code running after changing back to 3, 3, there was a large fireball over the whole screen.
Yeah, I saw that.
Briefly.
I saw that. I did see that. But it wasn't enough for me to be like, okay. What? What's happening now?
Is it possible Studio is having an issue during debugging when you change the type of the literal from int to float, and it's getting caught up, but that a restart
It's totally working.
would work?
What's going on? I know. I don't know what's going on, Rory. Why is it working?
Because we're back to 3 instead of 3F.
Yeah, but look at how well it's working. That's plus the dampening of the velocity.
Oh, I see. Yeah, fair enough.
All right, now I kind of want to bump this up. Let's do the 3F here again. Yeah, maybe there's something going up with the debugging that was a little weird. I'm not sure. Let's see if there should be no difference here. I want to get back to a world where everything makes sense again. There you go.
Here we are.
That's cool, right? So now it's looking a little more. It's a little more natural.
That's good.
Let me turn off the show live hand position so you see the effects just with the fireball. Yeah, I need to have it always in front of the hand when I'm back here like this. And I throw forward. See how it goes through right there?
Yeah.
Should not do that. Gotta tweak that. Way better. That's what I'm looking for. All right. Now that we're back in a real world where everything makes sense, let's crank this up. Let's make it 10. We're still cutting that velocity down in half on the other side of the equation here. What's happening? Why don't I see? Oh, it might be okay. I just don't have the... Nothing? What's happening? Oh, I don't know. It looks like maybe it just didn't have data. Okay. So just the 10 makes it move a little faster.
Yeah.
Let's try a 2. Yeah, 2's a little slower. Is the 3 really the number we started with really our magic number? Yeah, maybe we do it to 3. Maybe that's what we're going to do. Okay. All right, let's turn this off a second here. Let's see how the smoke looks with this. I'm most interested in the smoke. Yeah, it's still a little bit mechanical. It's not stretchy enough. Do you know what I mean, Rory?
Yeah.
Let's change this. Maybe this is a parameter we pass in based on the effect. Let's make this be make it 1.2. Let's make this be 8. That might help too, right? Bringing this number up, because then we'll get a little bit of oscillation around it, I think. That looked a little better already, I think. That's better. Yeah. Way better. Okay. Let's play with this just a little bit more. I'm going to make this a little stronger, and I'll make this degrade down even less, like that. All right, let's try that. Why did I get extras of these? Hold on. Yeah, I don't necessarily like the stronger here.
I think it's almost as if the not just the smoke, but the fireball, whichever one you're using, is attached to the hand and not catching up with the hand.
Wait, what's going on? Oh, I think that's... Sometimes we get... There we go.
So, for example, if you were to move your hand massively to one side, you would expect that the fireball would lag significantly, but then would accelerate towards the hand. Whereas what's happening now is it's going with the hand at the speed the hand does to very close to where it should be, and then doing the last part slowly.
Yeah. I think I need, let's do grade less. Let's see what we got. There we go. So there's more bounce as I increase this number right here. That 0.95, I get that closer to 1. There's more bounce in there. What are your thoughts on that, Roy?
That's better. Yeah.
Tell me what you're thinking. Does it still feel too stiff, not springy enough?
It's a little strange. If you were to put your hand, let's say, in front of where your face is, right, sort of horizontally anyway,
Yeah.
and you pull it all up there, and now you violently move your hand so that it is pointing upwards. Of course, that does cause a throw, so yeah, okay. Kind of
I
hard
can do
to
that.
detect at that point.
Like that. Is that what you're talking about?
I don't know. You're elastically connected to a point, but the elastic is so tense that although you're not on top of that point, you are... It's kind of hard to do. I imagine that if someone casts has a fireball attached to their hand and they move their hand quite far away without the act of throwing, that the fireball has to then travel to catch up. That one, that looks good there.
It's even bouncing in the z-axis, which I love.
Yeah.
Right? Because of what we did with the scale point. Right?
Yeah. That actually does look pretty good.
Let's tweak it just a little more.
You're very close to not having a deceleration or a dampening factor.
Yeah, I know. I need to have some.
Just modifications of K.
Yeah, I'm just going to change that right there. Let's try this one. Should be a little bouncier. That's way bouncier, I think. It's the dampening, that dampening effect at the end is what is going to determine. Yeah, I think I want more dampening is what I want. I feel like I'm just playing with this a little bit of numbers here on this.
Yeah.
Let's see what this looks like. Yeah, I'm feeling this. This is not bad. I'm going to go with this. Because I'm like, it's like when I'm holding my hand here, it kind of does feel like there's got its own kind of floating kind of connection. Yeah, that's got more of that feeling that I'm looking for right there. Cool. So let's see what the fireball looks like. Fireball. Fireball? Okay. It's like I'm hitting the button. Yeah, that's way better.
That's pretty good.
Look at that motion there, right? It feels like it's got its own momentum.
And it's much more apparent because of the pieces that are being given off by the fireball. The echoes, if you like.
Yeah. There we go. There's the close. I'm liking that better. Yeah. Okay.
Good stuff.
You ready for the next level?
Always.
We're going to get crazy now. Do you love it when I say that?
I do.
I'm putting on my wrist straps, man. We're going to write some code. All right, next thing. Here's what we're going to do. We're going to make it. This is the effect I want next. I want to be able to have the fireball in my hand like this. And I want to go like this. And I want it to shoot out in the direction of my hand. Now, how am I going to make it happen? It's a trick. It's misdirection. That has nothing to do with it. What I'm going to do at the same time.
What, no lip detection?
No,
Oh.
no. We're not doing that today. I'm going to hit a button, I think, on the keyboard. I'm thinking about holding down the control button.
Yep.
And I think that's going to launch it. I'm also thinking about creating stream detect buttons for different intensities. So I can do a soft one or a really, really hard one. But I think I'm going to right now just start with the control key down. So if the control key is down and I'm holding a fireball like this, I want to apply a force on it that's running in the direction from my palm to my fingertips. Yep. And have it shoot up. You can do some audio detection of the puff on the mic. Unfortunately, by the time this computer is getting audio, it's mixed in with Rory's sound. At the very least, yeah, it's going to be.
It was hard enough
I'd have to
get sound
rewire
working
things
on the show at all, with all the different composite pieces.
By the way, I got a new sound card in today, Rory. I was like, I had trouble with it on Sunday night at the Dragon Humper show, and I was like, oh man. So I'd had a second one, and I just finally installed it today. These, if you see these, I call these are not good. Don't get these sound cards. The ones I've got, much better. I'm really liking them so far. They're smaller, seem better made. I might be able to get you a link to those. So if anybody's out there's interested, let me know in the chat room if you want to see what those are. I can go bring up my Amazon history and look at that sound card. I think I'm actually going to bring it up now since we're talking about it. Sound enough to search for it. There it is. That's it right there. I am liking that.
See, the last time I needed to buy a sound card, it was decades ago. I've run with whatever's built into the motherboard now for so long.
Oh yeah, well, because of the complexity of the Dragon Humper show, I need at least 2 sound cards, and they're plugged into 2 different machines, and so that's what this one I really like. So far, it's been really reliable. I like the compactness of it. These had a lot of problems with the connector here. I have bought 6 of them. And I went through multiples of them, including things like this crazy stuff where the whole front and back just kind of pop right off of it.
Oh, wow.
Right? Yeah, no, these are cheaply made. And these are cheaply made. This one is well made.
I think it's probably worth pointing out, though, that these things you're referring to here as sound cards, they do much more than what a sound card back in my day would have done. This is closer to what's also now called an audio interface, so you can do things like plugging instruments and stuff into this and then balancing them against each other. There's lots of different inputs, I guess, is the difference. Rather than the sound card of a computer, which just sort of pushes sound out most of the time.
Yeah, okay, that's true. You do have inputs for sure. Okay. So I'm going to do that. That means I need a key down handler. Let's go ahead and close the app, and we'll go to our D&D app. We'll look for that control key down. I think I'm going to need a special event for this, as I recall. I think it's like system key preview down or something like that.
Sounds right.
Because it's a control key, but I'm not seeing system here at all. Preview. I guess I'll just go with preview. Key press. There's no key press either. All right. I'm going to do this. Hopefully that'll work. Oh, I've already got a preview key down. Let's go find that. All right. Oh, look, I'm already using it with the leap calibrator. Oh, right. We did this a while ago. Get rid of this. Yeah, I don't think this is going to work.
No?
Excuse me. Yeah, I think we're going to have to search for this. I just don't believe it's going to, they're not going to give me a, because I could hit Control R and they wouldn't want to trigger that event. They'd want to Control key pressed event. I just want to know when the Control key. Not if it's, I don't want to know if it's pressed.
See, I think this gets complicated because almost every other time, I mean, you're looking for literally tap the Control key and we're good, right? But in almost any other case, it's, oh, you're about to press something else, so we won't send an event until you've got the combination.
Yeah. Maybe I got to give that up. The reason I want to do the Control key is because it's my hand is low and out of the way of the leap, right? So it's over here. It's easy to hit secretly, you know, kind of thing. It's like it's right there.
Maybe you're just going to have a some kind of a timer that just checks if it is down at that moment. Create your own custom event.
I've got no events in keyboard. Coding Girl is suggesting maybe using a keyboard dot key down. I could do a loop that's just checking to see if it's pressed.
Yeah.
But maybe I got to give up on that. Maybe I do a Stream Deck command instead. We'll do a Stream Deck command. That's what I'm going to do. Because I've got another Stream Deck off to the side, and I could use that just by feeling it. I don't have to use my eyes. Like I can get a position and I can set it up so it's just dedicated. Because I don't use that second Stream Deck. I think I don't use it. Yeah, I think I'm going to do that. All right, so let's do the Stream Deck command. So let's come in here, switch over to this. Currently, I'm testing in this space right here. So let's create a new one. Paste. And do I want to call it hand effects? No, I do. I want to do.
You're almost firing the fireball.
Yeah.
Push. Yeah, push is
Push
good.
hand to fingers. Push toward fingers. Like that. Push.
Launch.
Yeah, because I think I want another one too. I think I want one where I'm holding it here. I want to be able to hit a button here where it just goes right towards the camera.
Right. So you do want to have something specific about the way in which it's launching.
Yeah.
That's inherent here. Along fingers.
Launch toward fingers. Maybe I'll do that. So it's going to be a launch kind of command right there. Launch. I'm going to get better pictures here, but toward fingers. So it's easier to see all of that. So we'll do launch toward fingers. And do I want to give it a velocity? I'm kind of thinking I do. So I think that's what the command is going to look like. So there'll be some sort of velocity push here like that. Okay. By the way, I'm really happy with that attach point code that we managed to figure out. without being mathematic geniuses. I'm pretty happy with that. Okay, so we need to create a new Stream Deck command. So we'll come in here. I've got, this is kind of a, oops, I don't want handeffects DTO, handeffects command right there. I'm going to duplicate this, and we're going to call this launch. Launch command. Are we going to have a launch DTO for this as well? No, I don't think so. I think what we're going to have is we're still going to call what is it? Trigger hand effects. No, I don't want to call that. I want to say launch like that, and then we want to pass in. We're going to have a launch command like that. We're going to have a data value, I guess, like that. And get rid of that and that. Get rid of all of this. Basically what I'm looking for is we need the word launch followed by a word followed by a number, I think.
Yep.
Okay. I think this one can be optional. I think that's the optional syntax, right? Is that right, Roy? Do you remember that?
That does sound familiar, yeah.
Okay, so we're going to do this. We're not going to have this anymore. If match success.
Coding Gorilla confirms our memories are operational, and indeed the question mark in that position does make it optional.
All right, cool. All right, message is in there, and then here we're going to now, we don't need to worry about any, we just got to break things up to the different locations is what we need to do. So we need to say the launch command is equal to groups.to.value. Do you concur with that, Rory? 1 is the whole thing, right? 2 would be this one right here.
I wonder if 0 is the whole thing and 1 is the first item.
I'm going to go with you on that one. All right, there's my launch command, and then my data value is going to be number 2. It's going to get from position 2.
And that's got to be conditional on it existing.
Thank you. Look at you, Rory. You're writing the code for me. I'm not even thinking.
I'm pretty sure you're the one in the front of the keyboard there.
All right, then we're going to send in our launch command and our data value. Wait. We need an else here. Right here. Like that. Okay. Passing in data value. All right. Launch. Should this be something different? Launch fireball. Launch hand effect. Launch fireball is kind of what I want to call this. Even though it could be,
sure,
you know, any other effect. Launch
effect.
Hand
effect.
tracking effect. There we go. Finally got something the pros, they'll let me work at a regular company with this method name finally. They'll be like, you're a pro, Mark. I like that name of that method you wrote today. I'll be like, hey, thanks, cool. All right, so now we're here, and I kind of want to set a breakpoint and figure it out. But what am I doing here? Leap device? Well, let's just throw it in there. Let's keep pushing it in. We don't have to maybe start running just yet. And we're going to do the same thing. I'm thinking about a coder's feature request.
Yeah.
Yeah, and it goes like this. The caret's here, and I do something that basically says, create that. It's like a push-in call, even though it doesn't exist. Does that make sense? Sometimes I find myself in this position where I'm kind of chaining responsibility to owned objects. Do you know what I'm talking about, Rory? I want to go from here.
Tell me again.
I'm go from here, and I'm going to push the signature of the method I'm in into the object right there.
Oh, I see. So delegate call, so to speak, or yeah.
Yeah, I'm thinking about that.
It's that's interesting. Yeah, I've definitely seen that before. You're sort of wrapping it. You're decorating it, so to speak, I guess is the official term.
Yeah. Okay.
Except you're turning yourself into a decorator of the thing that will be made.
Yes. All right. Launch toward fingers. Data value. I might do something like this. I might come in and say, I have a math EX. Oh, I thought I did. I thought I had to an int or something like that somewhere in here. What was it? I thought I had the math, a math something, math EX. Nope. Let's do this instead. Let's jump to the two int string extensions. Huh. Okay, cool. Isn't it there? I thought I just saw it. It's in D&D core. Is it just because I haven't used it yet? Is that what my problem is?
Possible.
I'm not sure what's going on. Yeah, it's not getting that should be an int. I think I gotta add D&D core. I think that's my problem. Okay. Okay. All right, so launch towards figures is here. I'm almost thinking about setting a breakpoint, but we have, at this point, I think somewhere we've got the objects we're tracking.
Yeah.
It's in skeletal data somewhere, I think. Well, actually, maybe I don't need that. I need, what is it, tracking? Oh, I thought it was here. Okay, maybe it's in hand 2D. If tracking, no. Come on, there's something here. solve for calibration. Let's go to skeletal data 2D. There it is. That's what I'm interested in. Okay. Yeah, I'm going to throw it down to skeletal data 2D, I think, is what I'm going to do.
Okay.
So what I'm going to do is I'm going to say skeletal data 2D got launched towards fingers. That's what I'm doing. Get rid of this. Does this take a default value?
Nope. Not currently.
Maybe like that. Okay. So it at least gets a 1 if nothing is specified. Okay, if tracking object in left hand. Actually, I think I just want to get the hand. And I don't have any method to do this yet. So I think what I want is something like this. Hand 2D hand is equal to get hand tracking. Get tracking hand, maybe is what I should call it. Get tracking hand. Like that. Okay, and then tracking hand is going to figure out which hand has got something in it. So I think we can do that with hand side. Here's my right, and then otherwise we're going to get out. Return null. Okay.
Yeah, that's good.
Now that we have hand side, all right, there's my code. What do you think?
Yep.
Good?
Yep.
All right. You're not talking to somebody else about getting groceries today, right? And you say, yep.
No, I'm not. No, that's good. We determine, because we have these two booleans that we could. I mean, see, that's an interesting point, though. We're tracking object in left hand and potentially object in right hand. So you're just going to effectively say that, okay, by default, the left hand is the one you care about most, because it's the one you'll encounter first. I believe it's your right hand that you use more, though, isn't it?
It is. You're right. It's a good point. I'm really only supporting at this point tracking one object. We're still a little bit away from juggling, right?
Okay.
Juggling fireballs. But actually,
Well, in any case, presuming that you have only one object in one hand, you will now return the hand that has got an object in it, which is broadly the point of this.
Yeah. And so now what we want to do is it's similar to a throw. Somewhere in here we've got, I think we're looking at throw code in here. We've got our thrown objects. Update virtual objects. World instances. This is just updating their positions right now. add instance, throw. Throws the tracked object and returns the index of that object. Where am I calling that from? Check for throw. So this is the vector we throw at it when we're like moving the hand and we let go of it. I kind of feel like from here down, there's the throw. And I think what I really want to do is, what's going on here? How can this return a negative if we're not tracking? Okay, so we'll already know that to be true before we set that in there. Can I do an extract method on this from here to here? Good. And we're going to say throw with vector. I don't know. Throw object. I'm going to do that. So there's my throw object call. That's in skeletal data 2D, kind of where I think I am when I'm working on it. Just jumping back to where we were. There we go. Yeah, throw object. First piece is the hand. Second piece is the position time velocity, the position velocity time piece, which I know I wrote in the last couple days, but already I'm like, what is that thing? And this is the second time. Yesterday I created a variable called K, and today I'm creating a variable called PVT. What am I doing? What am I doing? All right, so what's going on with position, velocity, and time? Oh, it's looking for the velocity, the position, the time. So when I said, oh, but I meant, I know that sounded like I was an idiot, but I was remembering what I was connecting it with here. So this is the leap velocity is the velocity of the hand as it's going through space. But I think I want to change it to just velocity. That's what I think I want to do. So I'm going to do that. I'm going to rename that to velocity. And now it's a more proper looking class. Let's do that too. Position, velocity, time.
I think originally the idea was that we expected it to have been populated from a value that the leap motion had given us, and therefore we should be understanding that it was in millimeters per second.
Oh, is that what was going on? Do we have any?
I think that was the logic.
Conversion?
A normal velocity that we would want to do mathematics on should be adjusted to be in meters.
Yes, I agree, but I'm not seeing any conversion on any of this. There's the assignment there. Add velocity. I have a feeling the palm.velocity. This is, nope, that's in millimeters.
Don't we allow it to go through in millimeters right up until the moment we need to do mathematics, like against gravity and so forth? So, i.e. in equations that require it to be like that.
I don't know.
I
feel like that's true. We did it, but I'm not seeing any kind of multiplication in any of this. I guess I'm not going to
just be in a physics kind of an area, wouldn't it?
No, it's not. I mean, yes, if I did good code, young man. All right.
I think one of the functions was get final velocity.
Yeah, no, that doesn't. I have a memory of that. That's not helping us. I can show it to you. Get final velocity meters per second. It's just.
I'm not thinking of that one. This was one in which you actually trimmed off a bit of a meters to pixels, or vice versa.
Yeah, it's this one right here.
So, no, you're right. Oh, just at the top there, just at the very top of the screen, millimeters per meter.
Whoa. There we go. Is anybody calling this? Oh, it is. There you go. You're right. 2 meters per second for the virtual
coding
3D
relevance,
object.
PYT. Sorry.
PVT.
PVT. Wasn't that a Michael Jackson song? That's PYT. Pretty young thing.
All right, let's jump back to where we were, see if we can kind of regroup in terms of what we're trying to do. Throw object here needs a throw vector. So the throw object is called here, throw vectors, get throw vector of hand, get throw vector. This is where we come in, and we basically come in and say the throwing point. So that throwing point is going to be, there it is right there, the position where the hand is. That position is equal to the position of here. Let's see, add velocity, get attachment point 3D. So it's just the 3D point of the hand, essentially. Get attachment point 3D. So let's do that call. So we're going to say PVT dot position is equal to get attachment in the hand dot get, no, where are we? Hand 2D, get attachment point, attach point 3D, it's in vector. No, it returns, it's in hand 2D. Is this private? Is that my problem? Okay. All right, so let's try again. Hand. No, hand. Get attach. Still no? Get attachment point. Okay, now I'm just confused. So hand 2D. Oh, it's static.
Yes.
Okay, and I gotta pass in hand. That's kind of weird. Why did I make that static? Oh, it's taking the other hand, isn't it? Ah. Okay, not quite what I want. Wait, I think this is called an assign to a value in hand. Yeah, it's the palm attach point. Oh, but it's the scaled point. I'm going to do this and that. Here. Okay, so that's not going to, oh well, I want to make it, I'll do this, but I'll make it internal, like that. Okay, so there's my palm attach point. It's set when we call set palm properties. So now, back over here, I've got the 3D attach point. Okay, position is taken care of.
Cool.
Velocity. Well, we need to figure that out. And the time is now. So we can do that part right there. Velocity, now we got to figure this out. So we want to go from the fingertips.
Well, the velocity's coming in from the method parameters.
No, that's the
That's the magnitude.
speed. The magnitude, yeah, that's the speed. Sorry, I should call that speed, like that. Okay, yeah, magnitude or speed. I need to get the vector here. And that's going to essentially be the fingertips minus the palm position. Do I have the fingertips? I got fingers in 2D, but that's it. All right, so we're going to do this. We're going to need to figure this out. We're going to need, in addition to this, we're going to need fingertips attach point 3D as well. What's this doing? Oh, I see. Okay. So what we want to do now, fingers. We're expecting to see 5 fingers here. Then what I want to do is I want to skip the thumb and I want to average out the next 3 fingers to get a point that's between all 3 of those. That's what I want to do. So I'm going to come in and say, we do for loop here. We're going to skip the thumb. So we're going to start at 1. And while it's less than 4, so I'll go to 1, 2, and 3.
Yep.
Then I'm going to say, I think I need a new vector here. Average fingertip point. And we're going to say it's a new vector of 0, 0, 0. Then we're going to say this. Do I got a plus equals on a vector? Wouldn't that be sweet? And we're going to say hand dot fingers of I dot what? Is there a position? Joint position? I don't think a tip position. That's what I want.
Yeah.
Okay, cool. The plus equals appears to be working. Then I want to say return this divided by 3. Do you agree with
Seems
that?
reasonable. Yep, I do.
Okay. Get fingertips attach point 3D. Fingertips attach point 3D.
I love the fact that the leap motion vector has overloaded the mathematical operators such that you can do this.
It's beautiful.
Otherwise, you'd be having to do it individually on each one of the coordinates, and that would be a massive pain.
Well, yeah, I'd do something. I'd probably go in and we'd either write an overload for us or we'd do something. Yeah. We'd do something. Okay. All right. Let's see, where were we?
We were assigning the vector.
There it is. So now this is going to go hand.
Velocity's vector in conjunction with its magnitude of speed, I guess.
Yeah, okay, so the velocity is going to be the fingertips attach point 3D minus that. That's going to get us a vector right there. Then I think where there's a normalized, cool, which I think is going to turn us into a times 1. Then I'm going to multiply that by my speed. So the time, when I say times 1, I mean normalized. What I mean is the magnitude of that, the length of that vector is 1.
It's going to reduce all the components' parts such that their directional magnitude is 1.
Yeah. And now I think I've got my position, velocity, time.
I think so.
Vector, my PVT. I feel like such a pro programmer using these
Oh yeah.
three letter variable names. I will almost never do that, but I'm like, really position, velocity, time. I'm really not sure what to call this thing here. Launch info.
It's kind of launch conditions, isn't it?
Yeah.
Set this, now say go.
Yeah, launch info and then throw. That might all work. Okay. Let's see if it does. Build has been canceled. Hand does not contain a definition of what? Did I rename that without actually... Hold on. Palm attach point 3D. This is not in... I've made a change here, but I don't quite understand the change that I made here. Palm attach point 3D is not in hand. It's in hand 2D. I think maybe that's what I meant to do there. I just didn't do the change right. Is that going to work? Oh, there it is like that. Okay. I think that might be it. What's my problem here? IntelliCode suggestion based on recent edits. Fingers.add new 2D finger 2D finger. What?
We suggest you do the thing that you are doing.
That's kind of what I'm looking at. It's just, I don't even get it. It's as if are you suggesting you want me to get rid of that? Based on recent edits? Maybe that's what it is.
Right. Yeah, that's it.
Okay.
Completely snowblind to the braces there.
I don't need you to do that to me. Okay, what's this? No. Shoot. Oh, it is. It's looking for a hand. Get attached point. Oh, maybe what I meant to say here. Oh, I know what I meant to say here. I meant to replace the whole thing with palm attach point 3D. That's what I meant to do. Because this is calculated in this called to set palm properties.
Right.
Right there. See it? So that's what I meant to do. Apologies for that. That's me, not being 100% aware of everything. How's my audio, by the way? It seems like it's a little low over here. Check.
Good for me, but
check.
How about for the stream? Are we good?
Yeah, it looks good on the stream. I'm looking at it looks like we're increasing the volume before it heads out. Seems like we're okay.
Yeah. Okay. Good.
All right. Wow, if this works, man, we're just. I don't know what to say. Can we claim to be really amazing, high-level professional programmers?
I think we can make that claim at any point. It's just whether anybody believes us or not that's maybe up for grabs.
Story of my life. Okay, here we go. Let's see what we got. Let's bring up a fireball. And now let's aim my fingers there. And now I'm hitting the launch button. I'm hitting the launch button. Nothing is happening. Nothing is happening. All right. Why isn't anything happening?
That's disappointing.
Oh, I know why. Somebody forgot to, I'm not going to mention any names. Someone forgot to register the Stream Deck command that they created. This is the launch command right here. We need to register this command. It'll never see it unless I register it. Let's move this type to file.
That's the story of my life. Write the incredibly complex, wonderful, and efficient algorithm, and then, don't use it.
Yeah, it's
or
funny.
Fail to return is usually the awesome thing.
When we created this architecture, I was like, we don't need automatic registration. Look at all of these I've had to add here, because I didn't add that into the architecture. We have it in another part of the architecture. We've got automatic registration. You just create a new class, descendant of something, and it'll find it at runtime and then register it. But these I decided not to.
It's a choice.
Yeah, it's a choice. And I still somehow insist that it's still not necessary to do it. Basically, if I add the registration, the thing is can I add the registration code in fewer lines than what you see on screen here? Maybe. So I delete these lines, add the registration code. I don't know. All right, we're up and running. Let's bring it over to the correct monitor. Activate. Bring up Fireball. Yeah, I'm loving, by the way, that spring effect now.
That is looking good.
Okay, and now let's shoot up for the fingers. Let's aim it in the right direction and hit the button. And hit, whoop. Yeah, hitting the button, nothing's happening. All right, let's go. Oh, wow. When I
What was that?
Alt-tab away, it's like, I think it stops getting the hand position data because I'm Alt-tabbing away to another window. That's what I think is happening. Okay, let's go set some breakpoints and see what's going on. Let's start here. Let's just hit the button. Okay, we're in. We got a success toward fingers. True. Okay, cool. Uh-oh. Oh, no. Oh. No, we're returning false, which means we didn't succeed.
Well, that just means we didn't match, so...
Yeah, I know, but we
Does
did
that mean
match because I didn't have this line of code here. That could make a big difference. Okay, let's continue to run. Okay. I'm not going to step into it just yet. I want to see if... I just want to go for the big bang for the buck and see if it works. There. And I'm hitting the button, nothing. Oh, wait.
Ah.
It's saying it's caught.
With throwing it and then catching it? Didn't we have a time delay on allowing that to happen?
I don't think so, but what if I did
Or was it
this? What if I made it 300 instead?
faster?
Yeah, throw faster. See what happens with it. All right, Fireball. I got to switch over back to the main app. Fireball. Whoa, kind of cool. Launch towards fingers. Go. Go. It is not making a difference.
It is not like it.
All right. Let's go get in the code. This might be a good place to stop. Right there. All right. Fireball. I don't like that color. Fireball. There we go. Launch. Okay.
Okay, we're getting there at least.
Yeah. Home attach point seems reasonable. Velocity. Fingertips minus the attach point. So let's see. Our Z is negative. Our Y is positive. Our speed is 300. It seems like it's not bad. Going into throw object. We're going to clear the history. Throw direction. Get vector throw direction. It's going to go forward is what it says. Okay. Well, I was kind of pointing it forward a little bit. Is it just that I need to keep cranking that up? Throw it by another order of
Maybe,
magnitude?
because if I look at those velocity figures, I figure they're just in the low hundreds. And that's hundreds of millimeters in a second, which is just a few centimeters. So unless we escape the range of your hand in like a second, you're going to catch again.
Gotta restart. Yeah, maybe that's true. To be honest, at this point, I'm not sure what those units are in. But if you're right, then you're right.
I like your conclusion.
I do too.
Yeah. I feel like nobody could fault us on that particular piece of logic.
You could say the same thing right back to me, in fact, or you can say, you know what, Mark? And if you're right, then
If
you're right.
right, you are definitely right.
Okay, if you're right, you're right. That's what we say.
There is, of course, a corollary to that, in that if we're wrong, we're wrong.
Nope. I want the smaller one. Okay, here we go. So there's that, and launch. Run. I'm not sure if I just caught that or not. I think the breakpoint threw me off here a little bit. with regards to time. Let's try again. Launch. Nothing is happening. It's not moving. I'm hitting the button, but nothing's happening.
Can you still throw normally?
Yeah, I think so. We'll do that real quickly here.
Okay. So, likely not broken the throwing logic on that basis.
By the way, this is so much better than when we first started, right? It's really like, it's really not bad, right?
It's like the determination of those magic numbers that sort of surround the naturalness of throwing it are just so much more on point.
Yeah, also the others, I haven't shown these, but the other ones over here, they kind of know whether to go behind my hand or in front of my hand, depending on where I'm showing it, right? So I can kind of go like this, right? And do these effects that kind of are looking pretty good. Oh, I'm hitting the button now. Nothing's happening. There we go. There we go. Like that. Yeah, it's kind of cool. Like that. Well, I wonder if these are using the attach point instead, the the springy attach point. I wonder if they are, because they seem like they're not quite lined up with my hand. Okay. Anyway, back over here. Why isn't the throw working?
Nothing is launching. It
We've
seems.
got. There must be something we're missing here. Let's go look at throw object. Throw vector. Check for throw. Nope, there's nothing that returns back. Get throw vector. Does that do anything at all? Set any variables that are not local. No. Let's go see what happens when we do a throw. What is our velocity? Let's just take a look at that.
Get an idea of the magnitude.
Yeah. Velocity is equal to. Okay, so it's like about -1,000, or -1,000, 1,000, -1,000. I'm looking at this number right here. So okay, that's what that is. Let's go look at our. When we get here, what's our velocity? Let's do the same thing. What's our velocity here? It's about the same. It's big.
Off, yeah.
It's big, yeah. Yeah, not moving. I think it's like, it's as if here's what my theory is on it though. My theory is that these aren't being set.
Okay.
And it thinks it's still tracking it. That's kind of what I think is happening. Because we're calling throw here, and this is where we set it to false. And we add the instance to the world. Are we calling this from ours? We need to call this from ours as well. I think we're calling it from throw object.
So it should be being called derivatively.
It absolutely should be called here. So throw object here. Calls throw.
Okay, so maybe
I want to go in
stick
here.
a breakpoint in here.
Yeah, that's what I'm going to do. Let's set a breakpoint right there. Take a look at what's going on. All right, one more time. Give me that fireball. And shoot towards the fingers. That should shoot it up. And what do we got?
False left and false right.
No.
Sorry.
Wait.
Oh, no, sorry. I'm looking
this
at two
was a
fault
knot.
It's not the same things.
Yeah. So it just set this.
I was looking at the other debugger visualizer, assuming it was the other hand, but it's not.
Yeah, so it just set that. It adds the throw vector here. Shoot. Oh. You know what this is? We renamed our property, but we didn't change
Oh, I
that.
see.
Or debugger display. Okay, well that all seems to be working correctly. The world is there. Now what is, we must be catching immediately is the next thing. It's gonna really, I don't care, just ignore it. Fine. Run. After it runs, then I'm gonna come in and delete it. So it's running and now I'm gonna come delete it. Haha. See, it could have done it, but I made it do it instead. Because it refused and I said do it anyway. Do I still have control here? I do. Okay, so now what I want to do is I want to look at, is it being caught? And let's see, where is that? Caught. Caught. Just caught. Let's see. Let's see if that's what's happening. All right, so fireball. Launch. It is not being caught. It's still tracking it. Do we have to send a message? Maybe it's we're not sending a message down below to let down below that it needs to now separate.
Okay.
Yes. Wait. Yes. Just, okay, hold on. Just caught has got a corollary called throwing.
Yes.
That's set to true. Oh, dang. And throw object, which we already verified we're calling.
Calling. Any chance instance index is coming out as something other than?
Yeah, we're setting a breakpoint here. We're going to just drill into this thing. I think it's what I should have done a long time ago. Launch towards fingers. Okay, here we go. Going inside. Yeah, Jesus, really?
Really?
They're like, we will win. That's all right. I'll get you next time. I'll get you next time, Visual Studio. All right, here we go. Clear the history. Get the instance index. It's 13. That's good to know. Hand.throwing is now true. Throw an object index. Hand throw direction is good. I still think
Direction is correct. It's up.
yeah. So I think all of this is good. Here's what I think we're failing. Check for throw. Check for throw. Remove out of bound instances. That's going to do just that. What's this calling from set from frame? Update data.
Update data.
I think that's what we have to do.
That's plausible, isn't it?
Yeah. But that's out in leap device, which means we really need to kind of do it here.
Yeah.
I think. Let's see if that's going to solve our problem. I
Will
hate
that be
it.
something that is conditionally done, or do we do that every time?
Yeah, this one right here. Well,
I just wonder,
it's every
do we
time
need
I'm
it in
going
the
to.
condition with the launch fingers.
Yeah, I think so. But you know, let's just see if this solves it though. Here we go. Fireball. Come on, fireball. They're punny. Visual Studios now. Wait. Hold on. Give it to me. Fireball. Oh, got to restart. All right. Did I not have that? Oh no, wait.
Breakpoint.
I'm in a breakpoint. Oh, thanks. I didn't see that. Okay, clearing the breakpoint. Back to the fireball. Come on, give me a fireball. All right, I'm gonna have to restart. It looks like. Here comes the restarting of the app. Yeah, I kind of have mixed feelings when this happens, Roy. On the one hand, I feel like it's validated our careful work. I mean, if it works, right? That our math was right, all of that. But on the other hand, I'm like, just this. It's like I hate that it's this kind of like side thing that I missed. Wasn't paying attention, right?